Hey everyone, it's the end of September. We're getting close to the release of Vendure version 2.1, and I want to talk about the subject of versioning in today's developer diary. So, versioning is the way that we know what version of a package or a library or a software product that we're going to use is. There's many different ways of doing versioning. You see, like for example, ECMAScript, they do yearly versioning. For example, my IDE is JetBrains, and they have a year, and then they have like a second number for the quarter or maybe half of the year. But by far the most familiar one to I think all of us developers, especially working with Node, the Node ecosystem, is semantic versioning. Just as a recap, semantic versioning is a versioning scheme with three main numbers like the major, the minor, and the patch. The patch version is used for bug fixes that don't introduce any new functionality. The minor version is used for when you introduce non-breaking new features, and the major version is used when you increment that when you introduce breaking changes. The selling point of semantic versioning, it's in the name, it's semantic. Each part of the version has a meaning. So as a developer, I can see if only the patch version increased, well, it's just bug fixes. That's safe. Whereas if the major version increases, it means there must be a breaking change. So I've got to pay attention when I do this upgrade. I've got to look at the change log, and I've got to figure out what the breaking changes are and what changes do I need to make, if any, to make to my code so that it's compatible and everything still works. So the idea is good. It's a sound idea, but there are some problems with semantic versioning. The main problem is this. What is a breaking change? What is a breaking change? It seems obvious, right? Yeah, we've changed the arguments that get passed to this API. This method no longer takes these arguments, but it now needs to be an object or whatever. The data type of something has changed. That's obvious. Those are obviously breaking changes, and I think that's clear. But other things can be breaking changes. What if a dependency of this package changes a major version? Are those breaking changes going to filter through to the consumers of our package now? Maybe you're sure that it won't, but are you really sure? There is a principle known as Hiram's law. This is from a software engineer, Hiram Wright, who works at Google. And this law states, with a sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody. And there's a great XKCD comic, as always, to illustrate this. So it's a changelog, changes in version 10.17. The CPU no longer overheats when you hold down spacebar. So what is this? This is a bug fix, right? It's not a new feature. It's not a breaking change. It's a bug fix. But then the comments come in. Longtime user 4 writes, this update broke my workflow. My control key is hard to reach, so I hold spacebar instead, and I configured Emacs to interpret a rapid temperature rise as control. So, I mean, this is a stupid example, but this illustrates that this truth of Hiram's law. If you have enough users, like every observable behavior, whether intended or not, whether you think it's a bug or not, can end up being depended on by somebody. And when you fix what you think is a bug, it can actually break someone's app that they've built on top of your package. So it's not theoretical, this is a real issue. And I think probably the most well-known package that not really suffers from this because they don't even do SemVer, but a case in point I would say is TypeScript, right? If you're a Vendure developer using TypeScript, if you're building for the web, you probably use TypeScript. You should use TypeScript. I won't get into that argument now. Right, TypeScript does not follow semantic versioning, although in your package JSON you will see three numbers, but in a minor increment there will be breaking changes. Now the TypeScript team are explicit that they don't follow semantic versioning. The reason they give, which is very understandable, is this. They're always trying to improve the capabilities of the type inference of their type checker. That means that if they improve the inference, then suddenly the type checker might pick up on some bad types, some type errors where it didn't know about them before. So suddenly your builder is broken. So they've not explicitly made a breaking change. They've not changed an API or anything. They've just made TypeScript better at figuring out types, and suddenly it's found bugs in your code and it's broken your code. So that's a breaking change, right? So they can't really follow semantic versioning. But we all live with it. We all use TypeScript. I think their non-adherence to semantic versioning actually doesn't cause that much of an issue. Right, so how does this manifest in the real world? The first problem is the perennial version 0. What I mean by this is there is a clause, somewhere here it is, in semantic versioning. It's not a big document. It's worth just reading through so you really get a handle on exactly how this works. But there is a clause here. Okay, number 4. Major version 0, that's 0.x.x, is for initial development. Anything may change at any time. The public API should not be considered stable. So this is kind of a little get-out clause that some package maintainers like to use or abuse. And it basically means that as long as you're not yet at version 1, major version 1, you can break anything in any version. You can issue a patch release which like completely changes the public API. That is okay. That is compatible with semantic versioning. And the reasoning for it is okay. Like if you're building a new library and you don't really know how everything should work yet, but you want to get something out there, get people testing it, you can do a version 0. People can test it. You're not locked into those API decisions which have not been yet validated in the real world. So of course it makes sense. But what you sometimes see then is that library authors just stay on version 0 forever. We are Vendure is depending on type ORM, for example. Let's have a look. Type ORM. So type ORM is, it's been around for years. It's got 1.4 million weekly downloads. It's stable, right? It's not like a pre-release. It's stable. It's used widely in production. Yet the version is 0.3.17. So in theory, they could release 0.3.18, which could be a completely breaking change, according to semantic versioning. Now, luckily, they don't do that. In recent years, they've treated the minor increment as a breaking change. So going from version 0.2 to 0.3 was quite a breaking change that we actually navigated recently. But they're on version 0. There are a lot of popular libraries that stay on version 0 for indefinitely, perennial version 0. Famously, React was on version 0 for a long time, up to 0.15, I believe. And then at one point, it just became kind of absurd that they're on version 0 when it was like the most popular front-end framework. So then they just skipped it and went straight to major version 16. So that's one issue with SemVer. Then on the other hand, people will say, well, versions are cheap. Well, why not just update your major version? Or, you support a different node version, you update your major version, right? It's not like there's a finite number of major versions available that you have to then guard. You could increment a major version like every time if you want. And if you take Hiram's law into account, why don't we just increment everything to a major version just in case, so that we can be really explicit that, there might be a breaking change. We don't think there is, but there might be, so we're going to increment the major version. Now, this leads to another problem, which is like the problem of having like hundreds of major versions. Because here's the key point is versions need to communicate information. Semantic versioning is an explicit attempt to communicate information to not just to humans, also to machines, compatibility and so on, but also to humans. Like when it's time to update a library, you kind of want to have an idea of like how different this new version is from the version you're currently on. Major versions are a significant part of your calculus of like how much of a change should I expect. So here's a great thread on this topic from Anthony Fu, who is an open source developer mainly active in the Vue ecosystem. And he proposes a new 4-digit semantic versioning scheme where you've got an epoch followed by a major minor patch. The epoch digit indicates an overhaul, rewrite, or massive update that usually requires migrations or for marketing. And again, he makes the point that a new major might just be the fact that you updated one of the dependencies, which technically could inherit one of the breaking changes, but it might only affect 0.01% of your users. On the other hand, to increase the major version every week, you get the problem where, like, for example, a package version 87 actually is not that much difference from version 24. And this makes it really difficult to communicate the actual magnitude of changes. So this is why he proposes this overarching new number, epoch, that really clearly communicates, okay, this is now a big change. There are going to be migrations. You better pay attention to this. Now, this is not something that's going to become a reality anytime soon. So what can we do? Last year, I made an RFC on the Vendure repo proposing some changes to Vendure's versioning policy. At the time, we were on version 1.0, and we were running into this, like, we have lots of dependencies. We're a big package, right? And I was trying to strictly follow semantic versioning. I didn't want to update these packages that we depend on because they could technically become breaking changes. At the same time, I didn't want to increase the major version every time there was some potential theoretical or maybe technical reason that it could become a breaking change. So I wrote up this proposal that we follow what I called a relaxed semantic versioning, where in a minor version, it would be okay to update a dependency. So then we could keep up to date with type ORM, with Nest.js, with GraphQL, with Apollo server, because those are important things. And the feedback was from, I think, 100% of the people who responded to this was, yes, this is what we want. We want to stay up to date. We want to have clear communication about when real big changes are coming and when it's just some smaller update. And since version 2, this is the policy that we've now implemented. But this is the first time I've really talked about it beyond this RFC. I will also be adding this to the documentation so it's clear. Because again, the version is about communication. And as long as we can communicate effectively the information required by developers, then we've fulfilled the purpose of the version. So if we have this relaxed SemVer policy, as long as we make it clear and explicit to developers what to expect from a minor version versus a patch versus a major version, then they can work with that. So with all that said, version 2.1 is coming out soon. In this version, we've updated the major dependencies, including moving from Apollo server version 3 to version 4. And if you have custom Apollo server plugins that you've written, then there's some migration you'll have to do. It's quite small. Also, we've upgraded the versions of GraphQL and Nest.js and other dependencies. Most of the dependencies have been updated. I'm not going to go over the features in this video. I've teased a few already in past videos, but at the time of the release, you'll find out all about all the cool stuff coming. Okay, and that will be in the next couple of weeks. So keep your eyes peeled, and I'll see you next time.